going to be doing Article 210 through 210.6, just the very beginning of the code. And what it's going to talk about is multi-wire branch circuits. This is kind of get down to what this all means. So it starts out with the word multi-wire branch circuit. What essentially that means is, if you don't know, it's a circuit that has several ungrounded conductors, a couple of hot wires, and a neutral. This used to be real common. They used to run 3 hot wires per neutral, and that's just the way they did it. And although we don't do it that much anymore, according to the code, it shall be permitted. It is a permissible way to install electrical wire. However, 210.4b, disconnecting means shall simultaneously disconnect ungrounded conductors. So what this is essentially saying is that the circuit breaker for a multi-wire branch circuit, if it's 2 hots and a neutral, it's going to have to be a 2-pole breaker. It's going to have to disconnect the 2 hots at the same time. If you were to have 2 single-pole breakers, it wouldn't meet this qualification because it wouldn't simultaneously disconnect all ungrounded conductors. So if you have 3 conductors in a neutral, you're going to have a 3-pole breaker that simultaneously disconnects all ungrounded conductors. So this is a thing inspectors get jammed up on all the time. You should pay attention to it. C, 210.4c says it shall only supply line to neutral loads. That is, in a 122.08 system, the multi-wire branch circuit is only going to supply the 120 volt loads. It won't supply the 208 volt loads. 2 exceptions though, and I think these 2 exceptions actually overrule the entire C. The first exception is it's a single piece of equipment. If you have a dishwasher or you have a industrial washing machines, industrial like the Hobart machines, a couple of water heaters. They all do this. If it requires 208 and 120 volts, like the dishwasher heater is 208 volts and all the control unit is 120 volts, it's in one plug. It's a 208, 120, 2 hots, neutral, 2-pole breaker, totally good. It supplies 2 different voltages. It's a single piece of equipment. That's exception 1. So exception 2 is, of course, that all ungrounded conductors are open simultaneously by the overcurrent device. So what that means is, if you use a circuit breaker, which is an overcurrent device, and it opens up all the ungrounded conductors of that multi-wire branch circuit, then it is acceptable for them to supply either 208 volt loads, 2 hots, or line to neutral loads. And I think there's a little bit of nuance here in that you could have a disconnecting means that simultaneously disconnected all ungrounded conductors, like a 3-pole knife switch or something like that. But in effect, the way we do that is the disconnecting means that simultaneously opens all the ungrounded conductors is going to be a circuit breaker. It's going to be a 3-pole breaker or a 2-pole breaker, and a 2-pole breaker is an overcurrent protection device. So in the event that you're using a 2-pole or 3-pole breaker to open all the ungrounded conductors, then you have met exception 2, and you can use it to supply both 120 volt, 208 volt loads, or all right, so the code goes on to require that you identify conductors, and it essentially says the grounded conductor, the neutral, and it refers to another code section, 200.6. And it goes like this, and they're real consistent. If your conductor is under 4 AWG, it's going to have the neutral finish. It's going to be gray or white. And if it's over 4 AWG, it's going to be identified at every one of its terminations or splices as gray or white. The code's real consistent, so this code section doesn't list those things. It just refers you to code section 200.6, where it tells you how to identify grounded conductors. Grounded conductors are neutral conductors. There you go. Almost all. Okay. Identify the ground wire. Again, it doesn't tell you how to identify the ground wire. It just references this other code section, code 250.119, and in this very consistent way says, if your wire is under 4 AWG, your wire is going to be green. It's going to be green. It's going to be green with yellow stripe, or it's going to be bare copper. And likewise, if it's over 4 AWG, it's going to be identified at all of its termination points and all of its splice points with green marking. And most of the time, that's going to be like green electrical tape. It can also be like a shrink tubing, although in practice, green electrical tape. There you go. The ungrounded, the hot conductors are this is the portion of the code where it identifies how you should identify your hot conductors. So the hot conductors cannot be white and they cannot be green. It says essentially that you must have a panel schedule. You must list where these conductors go and what the color code or the specification that you used to identify what kind of voltage is going into these wires that you used. The code is real loose or permissive when it comes to how you do it. In practice, we identify every box, we write the voltage on the box, we write the circuit number on every box, and we color code the wires for their voltage. In general, we color code them black, red, blue, and that's going to be 12208, and then brown, orange, yellow for 480. So that's generally the way they do it, but it's not required that you do it. It's not required that you use that exact color code, although it is industry practice, and if you use a different color code, it's going to be real jammed up. So try and use that color code, but you must identify for the voltage. And the best way to do this is if you color code in the standard way that we generally color code, and to identify and label every box. Then you're going to be covered. The inspector's not going to jam you up, because he's going to know what the color code means. The color code is going to be listed on the panel schedule. It's going to say, oh, brown, orange, yellow. Brown is going to be A phase, orange is going to be B phase, yellow is going to be C phase. No problems. Just having that color means that's the voltage it is. Also, it's written on the box what voltage it is. Inspectors aren't going to have a problem with that. You have to, but it is permissible by code to use any combination of labeling or color coding that is not industry standard, as long as that thing is put onto the panel and available and people generally know what it means. There you go. So this section also goes through DC, like DC circuits. So one of the most important things to know about this code section is we're dealing with DC circuits of 60 volts or more. If a DC circuit is 60 volts or less, it doesn't apply to this code section at all, and you need to look up a low voltage code section or freedom, do whatever you want. But so this is DC 60 volts or more. So code is real consistent in this. If your ungrounded conductor is 4 AWG or more, you can run it in basically black, and you can identify at every splice point, and you can identify at every termination whether it is positive or negative. Because we're dealing with DC current in here, we're just going to have positives and negatives. And so they give us this real tight color code. The terminations on this. Terminations will be, for positive, they will be red, or they will be a conductor with a red stripe, or they will be, if they're 4 AWG or larger, they can be identified at every termination with either a red stripe or basically shrink tubing that says positive on it, POS or a plus sign. All those are acceptable. So either red, a conductor that's not black with a red stripe down it, or positive or a plus sign. All those things are going to be acceptable. Negative is going to be black, or it's going to be a conductor that's not red with a black stripe. And the reason they do this is they want to give you a little bit of leeway. Like, once you've used all the red wires that you can and all the black wires you can, you are going to want to keep some things separate. So if you wanted to get, and it's really easy to order this stuff, according to this code section, you run DC, you get a yellow wire with a red stripe. That red stripe means it's positive. You get a yellow wire with a black stripe, black is negative. You could be like, oh, all the DC power that goes out to that branch is all yellow. And you'll know whether it's positive or negative because it has a red stripe or a black stripe. So that's why it's not just black and red. You can have any color conductor with a black stripe, except red, or any color with a red stripe, except black, and that'll be positive and negative. It's very common in equipment that comes out to the field to have this printed shrink tube positive, negative on it. So that's why they put that in the code. So that is essentially Article 210 through 210.6. And come back, we'll do 2.6 and up.